You see it tonight, moving against the stars. A visitor from beyond our sun, from beyond our neighborhood, cutting through our solar system at speeds we barely comprehend. They told you it was coming. July 1st, 2025. Atlas. Survey telescope in Chile catches something wrong, something that shouldn't be here. Within hours, the math confirms it. Orbital eccentricity, 6.139. That TM, it's not a typo. Anything above 1 means it doesn't about TMs belong. This thing came from interstellar space, third object ever confirmed. They named it 3I Atlas. If you value documented astronomy and space science like this, subscribe. I too, TMs, the best way to support our work. Also comment from which city you TM are hearing this from. Also, this script is researched and factual, using sources from NASA TM's Jet Propulsion Laboratory navigation reports filed by Davide Farnocchia in October 2025, and peer-reviewed papers in the Astrophysical Journal letters, including JWST NIR spec observations, published August 25, 2025, by Martin Cordner and collaborators. WOW TMR, pulling from monthly notices of the Royal Astronomical Society, research by Bolin and team from summer 2025, and real-time tracking data from the Minor Planets Center, with over 4,000 observations from 227 observatories worldwide between May and September. Now back to the information. Right ascension 180727.68. Declination negative 1841.40.2. The object moves 73.31 arc seconds per hour against the background stars. Fast. Too fast for anything trapped by our TNM's gravity. Pre-discovery images surface within days. Zwicky Transient Facility caught it June 14th, 3 weeks before official discovery. Atlas Hawaii telescopes, same thing. Even the brand new Vera Rubin Observatory grabbed frames between June 21st and July 3rd during validation runs. It was already there, already screaming toward us. The numbers tell the story nobody wants to hear. Hyperbolic trajectory, eccentricity so extreme it makes the previous 2 interstellar objects look tame. 1I Oumuamua had eccentricity 1.2, 2I Borisov sat at 3.6, 3I Atlas clocks in at 6.139, highest ever recorded. Hyperbolic excess velocity, they call it. The speed it had before our sun even touched it. Oumuamua entered at 26 kilometers per second, Borisov at 32. This thing doubles them. Something ejected 3I Atlas from its home system with tremendous force. Gravitational kick from a massive planet. Close encounter with a stellar companion. Maybe something worse. Not the thin disk where young stars live. The thick disk. Old stars. Metal-poor stars. Stars that formed when our galaxy was young. University of Oxford astronomer Matthew Hopkins runs the numbers. If 3I Atlas came from the thick disk, it has been traveling for 7 billion years. 7 billion. Our solar system is 4.6 billion years old. This object predates Earth by 3 billion years. Oldest comet ever observed. Not by a little, by an epoch. The coma spans 26,400 by 24,700 kilometers. Twice Earth TM's diameter. But the nucleus, the solid core that stays hidden, dust surrounds it, reflects light, makes size estimates impossible. Then Vera Rubin data drops it to 6. Hubble tightens it further. But the dust cloud, the coma, it contaminates everything. Most likely diameter sits below 1 kilometer, similar to Borisov. But there, TM's a problem. A massive problem that shows up in the mass calculations. 470 million kilometers out. The spectra come back, and everyone goes quiet. Carbon dioxide dominates, 129 kilograms per second pouring off the nucleus. Water vapor, 6.6 kilograms per second. Carbon monoxide, 14 kilograms per second. Carbonyl sulfide, 0.43 kilograms per second. The ratio stops everyone cold. Carbon dioxide to water, 7.6 to 1. Highest ever observed in a comet. Not close. 4.5 sigma above the trend line for long period comets. 6.1 sigma when you exclude outliers. Either it formed beyond the carbon dioxide ice line in its parent system, out where temperatures drop low enough for CO2 to freeze, or its ices saw radiation exposure far exceeding anything our comets endured. Interstellar cosmic rays, high-energy particles, billions of years of bombardment while drifting through the void. September, astronomers compile 4,022 observations, 227 observatories worldwide. May 15th through September 23rd. Minor Planet Center coordinates everything. They plot residuals, deviations from a pure gravitational trajectory. Between May and September, nothing. 0 deviation. Upper limit, 0.028 arcseconds. Translates to non-gravitational acceleration less than 15 meters per day squared. Nucleus diameter exceeding 5 kilometers, probably larger. We should have found hundreds of thousands of small objects before detecting one this massive. The reservoir of rocky material in interstellar space, canning our TMT supply objects this large at the rate implied. Statistical probability of finding 3I Atlas before finding 100,000 Oumuamua scale objects sits below 1 in 1,000. 1.36 AU, 203 million kilometers between Earth and Mars orbits. But Earth arousal TMs on the wrong side. Solar conjunction. The comet disappears behind the sun. TMs glare from our perspective. Perfect timing, or perfect planning. High-rise camera, 0.5 meter aperture, captures frames at 30 kilometer per pixel resolution. Closest observations ever obtained, distance 10 times better than Earth-based telescopes. ESA ExoMars. Trace gas orbiter joins in, takes images October 1st through 7th. Cass's camera catches the coma, the dust cloud. Triangulation between Mars orbiters and Earth telescopes improves trajectory prediction by a factor of 10. Tenfold accuracy boost. Multiple wavelengths, and they all see the same thing, rapid brightening, far beyond normal cometary behavior. Color photometry shows distinct blue tint, bluer than the sun. Davide Farnacchi, navigation engineer at NASA JPL, PhD from University of Pisa. Files report late October. ALMA data, Atacama, large millimeter array. 3I Atlas appears 4 arcseconds away in right ascension from predicted position on October 29th. 4 arcseconds. Translated to acceleration. 135 kilometers per day, squared radially away from sun. 60 kilometers per day, squared transverse to solar direction. Non-gravitational acceleration, confirmed. James Webb schedules December observations when comet reaches closest approach to Earth. December 19th, 1.8 AU, 269 million kilometers. Published 11 papers on 3I Atlas between July and November 2025. Examines every anomaly, lists them by probability. 9 anomalies total. Jupiter TM's Hill radius, the boundary where Jupiter TM's gravity dominates over the Sun TM's, measures 53.502 million kilometers. The match sits within error bars, probability of random alignment 4 in 100,000. The non-gravitational acceleration at perihelion enabled this precise targeting. Lagrange points L1 and L2 sit exactly at the Hill radius, perfect place to park satellites. Minimal fuel requirements for orbital corrections. Moving faster than both. We should not have detected this object third, probability less than 1 in 1,000. Non-gravitational acceleration requiring massive evaporation. Yet preliminary images show intact nucleus. Engine propulsion needs far less mass ejection at higher exit velocities. Chemical rockets use exhaust speeds 3 to 5 kilometers per second, 10 times faster than sublimation speeds. 3. I-Atlas coma contains 96% non-water volatiles. Could be surface accumulation during interstellar journey, or could be technology that collected ice as shielding. To absorb enough sunlight to sublimate sufficient ice for observed mass flux, nucleus needs unreasonably large surface area. Observed dust loss rates 66 kilograms per second. Expected nucleus size makes this problematic. Technological thrusters done up TMDT have this constraint. Jet outflow speed measured at hundreds of meters per second, 1,000 times slower. Ram pressure scales with speed squared means jet density must be 1 million times higher than solar wind. Few protons per cubic centimeter. Mass flux calculation over jet area gives 50 billion tons per month total mass loss. Comparable to minimum calculated mass of 33 billion tons. If that TOPS-IM is real, comet loses everything in 1 month. Completely inconsistent with intact nucleus observations. States clearly that outgassing naturally causes non-gravitational acceleration. Seen in Oumuamua, seen in short-period comets. Spitzer observations confirmed Oumuamua outgassing despite no visible coma. 3I Atlas shows active coma. Hubble and JWST data support cometary composition. Carbon dioxide, rich, yes. Unusual, yes. Impossible, no. 3I Atlas, consistent with natural cometary origin. Icy planetesimal ejected from parent system, gravitationally scattered. Spent billions of years crossing galaxy. Felt our TM's pull. Followed hyperbolic path through inner solar system. Properties match expectations for object formed around different star. No evidence suggesting artificial origin. No evidence requiring technological explanation. Brian Cox, science communicator, argues forcefully for natural interpretation. States 3I Atlas definitely natural comet. Lobe counters that Cox wrote 0 peer-reviewed papers on 3I Atlas. Acts as popularizer, not researcher. Debate intensifies through November. Public splits. Media runs wild. Headlines scream alien probe. Other headlines mock speculation. Ground-based observatories track the comet through November. Gemini South Telescope in Chile, 8.2 meter aperture, catches anti-solar tail growing. August observations showed 30 arcseconds angular length, 56,000 kilometers actual length. Tail becomes more prominent as viewing geometry improves. Very large. Telescope detects cyanide emission. Atomic nickel vapor, concentration similar to solar system comets. Nickel emission at 4.6 grams per second. Cyanide at 17.6 grams per second, both increasing steadily as comet approaches Sun. July through August, measurements show rapid, steady rise. Swift Observatory, NASA Aura TM's ultraviolet telescope, detects hydroxyl ions and water vapor July 30th and August 1st. Water ice confirmed by Gemini South and NASA Infrared Telescope Facility July 5th and 14th. Sphere-X Space Observatory images. 3I Atlas mid-August. Multispectral observations spanning 0.6 to 5.3 micrometers. Carbon dioxide cloud extends at least 348,000 kilometers radius, only visible in near infrared, far larger than optical coma. Nickel confirmed same day. November brings new observations. Ground-based telescopes regain line of sight as comet emerges from solar conjunction. Northern Hemisphere observers catch it at twilight, still faint. Magnitude 12 to 13. Requires 8-inch telescope minimum for visual detection. 12-inch telescope better. Diffuse nature makes it challenging, not a point source. Extended coma makes it dimmer per unit area, but it TM's there, moving through Virgo. Heading toward closest Earth approach. Tracking gas emission rates. NASA states clearly no evidence for artificial origin. ESA confirms natural comet classification. Mainstream astronomy stands firm. 3I Atlas is a comet. Unusual comet. Remarkable comet. Oldest comet. Fastest comet. Most carbon dioxide rich comet. Comet with strange trajectory. Comet with odd jets. Comet with statistical anomalies. But still a comet. Hyperbolic excess velocity, 58 kilometers per second. 7 billion year age. Nucleus mass exceeding 33 billion tons. Non-gravitational acceleration, 135 kilometers per day, squared radial. Blue color, exceeding solar temperature. Carbon dioxide to water ratio, 7.6 to 1. Perigove alignment within 60 kilometers of Hill radius. Arrival timing, placing it behind Sun during perihelion. Jets maintaining collimation across million-kilometer scales. Combined probability approaching 1 in 1 billion or worse. More Webb observations scheduled. More Hubble time allocated. Ground campaigns continuing through January. Closest approach, 53.445 million kilometers. Exactly Hill radius, then gone. Back into interstellar space, back into the dark. 7 billion year journey continues. Next star system could be a million years away, could be 10 million. Does now matter to something that already traveled 7 billion. Ancient artifact drifting through galaxy? We may never know. Every observation supports comet classification. Every observation also reveals anomalies that should not harm MUT exist together. Trajectory placing it in perfect position for observing Earth-Sun system. Acceleration vector aligned with Sunna TM's direction. Smaller size, making natural explanations barely plausible. 3I Atlas splits the difference. Shows clear cometary features, active coma, gas emission, dust production, composition suggesting icy body, but layered with anomalies requiring explanations that stretch natural frameworks. Each anomaly individually explainable. Collectively they form a pattern that makes you pause. Null hypothesis assumes natural origin until proven otherwise. Burden of proof sits with those claiming artificial nature, as it should. Telescopes and spectrographs CANO, TM, TT detect intent. CANO, TM, TT measure purpose. CANO, TM, TT determine design. They measure photons, wavelengths, brightness, position, velocity, chemical signatures, physical properties. More massive. Wrong composition, strange acceleration, blue color, precise targeting of Jupiter, perfect timing relative to Earth. Jets that shouldn't maintain coherence. Mass loss that should now TMT allow intact nucleus. Statistical clustering that should now TMT occur randomly. Survey telescopes improving. Vera Rubin Observatory begins full operations. LSST, Legacy Survey of Space and Time, will spot dozens of interstellar visitors per year, maybe hundreds. Statistics will improve. Sample size will grow. Patterns will emerge. If we keep seeing these patterns, Natural origin becomes only explanation. If 3I Atlas remains unique outlier, questions intensify. VLT detecting nickel and cyanide, SWIFT measuring water production, Sphere X mapping carbon dioxide cloud, every telescope that could point at 3I Atlas did. Every instrument available recorded what it could. Peer review filters errors. Replication confirms findings. Truth emerges from process, not proclamation. 7-billion-year-old relic from the early galaxy, messenger from a protoplanetary disk that formed before our sun ignited. All of them out there, drifting between stars, occasionally passing through another system in TM's space. How many will pass through 1,000 years from now when we have instruments everywhere? The final data point sits in trajectory predictions. September 25th, paper by Cloete, Loeb, and Veries, Minor Planet Center Observations, 4,022 data points, May 15th through September 23rd. 0 deviation from gravity between May and September, upper limit 0.028 arcseconds, non-gravitational acceleration below 15 meters per day, squared during that period. Suddenly, acceleration appears. 135 kilometers per day, squared radial, 60 transverse. Timing matters, distance matters. 3I Atlas showed no push when far from Sun, showed significant push near perihelion, when Sun heated nucleus, when volatiles should sublimate fastest, when rocket effect should be strongest. Acceleration increases, standard physics, except the mass loss calculations done at TMT support intact nucleus observations, except the jet collimation exceeds normal outgassing patterns, except the timing perfectly aligns with Jupiter targeting, except probability of random occurrence sits below 1 in 10,000 for that parameter alone. Product gives combined likelihood of natural occurrence. Number drops below 1 in 1 billion, maybe lower. Depends on exactly how you calculate individual probabilities, how conservative you make assumptions, how much benefit of doubt you grant to natural processes. We have observed 3 interstellar objects, not 1 billion, 3. Finding the anomaly in position 3 instead of position 1 billion means either we got incredibly lucky, or the probability calculation missed something critical, or the object is no or tamped what it appears. Independence assumptions especially. If anomalies correlate naturally, if some physical process links them, combined probability increases dramatically. Maybe carbon dioxide richness naturally leads to tight jets. Maybe high velocity naturally correlates with large mass for interstellar population. Maybe trajectory timing, purely selection effect. We only discover objects when geometry allows observation. But each assumption requires justification. Each correlation needs physical mechanism. Each selection effect needs demonstration. Until those exist, probabilities stand as calculated, uncomfortable but real. Difference, 57 kilometers, within error bars. Non-gravitational acceleration at perihelion enabled this targeting. Without that acceleration, trajectory would miss. With it, trajectory hits. Precision troubling. Jupiter L1 and L2 offer views of inner solar system. Earth, Mars, Venus, Mercury, all visible, all accessible to instruments placed there. Or nothing happens. 3I Atlas passes Jupiter cleanly. 57 kilometers difference between closest approach and hill radius remains coincidence. Statistical fluke. Bad luck for those hoping for proof. Good luck for those arguing natural origin. Either way we get data. Either way we learn. Either way science advances. Best viewing opportunity from ground-based telescopes. Last chance before comet recedes into outer solar system. Last chance before faintness makes detailed spectroscopy impossible. Every observatory capable of tracking 3I Atlas will. Every instrument capable of measuring composition will. Every astronomer interested in interstellar objects will contribute data. December 20th, 2025. Day after closest approach. When preliminary data starts arriving. When spectroscopic measurements reveal final composition details. When images show nucleus integrity. When gas production rates confirm mass loss mechanisms. When scientists present findings at conferences. When papers enter peer review. When consensus begins forming. Natural comet with extreme properties but understood physics. Or technological artifact disguised as comet but revealed through statistical clustering of anomalies. History decides, not opinion, not speculation. Data decides, evidence decides, reality decides. Human civilization will rise and fall before 3I Atlas meets another sun. Our observations, our measurements, our debates, all that becomes cosmic footnote. Brief moment when one species on one planet looked up and saw a visitor from another star. Future generations will have better instruments, better telescopes, better spacecraft, better understanding. They will look back at our observations of 3I Atlas and judge how well we did with what we had. Did we let evidence lead rather than assumption? All of it testing predictions, all of it advancing understanding. Those gaps matter, not because they prove alien technology, but because they reveal limits of current knowledge, areas where models break down, places where understanding incomplete, questions demanding further research, opportunities for discovery. Through objects like 3i Atlas that force us to expand frameworks, natural or artificial, understood or mysterious, 3i Atlas already succeeded in pushing astronomy forward, already generated papers, already sparked discussions, already revealed that interstellar space contains diversity we barely imagined. When heavy elements were scarce, when protoplanetary disks looked different than ours. Whatever system birthed 3i Atlas, whatever disk condensed its ices, whatever process ejected it, all of that happened before our sun existed, before our solar system formed, before Earth, before life, before anyone to observe. Far in human terms, close enough to study, far enough to pose no threat, perfect distance for observation, perfect geometry for science, perfect timing for astronomy that can actually respond. 3i Atlas would have passed unnoticed, unknown, unrecorded. Direct proof. And that knowledge says 3. I Atlas came from interstellar space at 58 kilometers per second. Arrived July 1st from direction of galactic center. Showed carbon dioxide richness 7.6 times water. Exhibited non-gravitational acceleration 135 kilometers per day, squared at perihelion. Maintained a jet collimation across million-kilometer scales. Brightened rapidly and turned blue near sun. Line trajectory to pass within 60 kilometers of Jupiter Hill radius. Clustered 9 statistical anomalies, each individually explained but collectively improbable. The answer sits in data yet to arrive, observations being taken right now, photons traveling from 3i Atlas toward Earth-based telescopes. Light travel time 1.8 AU means 13 minutes. What we see now left the comet 13 minutes ago. Real-time impossible across cosmic distances. Always watching the past, always seeing where objects were, not where they are. When 3i Atlas comes closest to home, when questions matter most, when answers begin emerging, when science confronts mystery, when evidence meets speculation, when probability faces reality, when one civilization watches visitor from another star and wonders what stories it could tell if it could speak. 7 billion years of travel, 7 billion years of silence, 7 billion years of cosmic solitude. And then, briefly, one night in December 2025, close approach to third planet orbiting yellow dwarf in galactic backwater. Observed, measured, recorded, remembered, and then, once more, onward into the dark. Gas cloud exceeding solar wind ram pressure, all of it pointing towards sun while simultaneously pointing away. Bidirectional emission, sustained across distance that should dissipate any natural outflow, yet there it sits, imaged, undeniable, requiring explanation that either expands our understanding of cometary physics or confirms our suspicion that 3i Atlas represents something we have never encountered before. Something that changes the questions we ask when we look up at night and see stars that might have sent their own messengers. Messengers that passed through millennia ago, messengers arriving tonight. Messengers we will only recognize if we remain willing to see what the evidence actually shows, rather than what we expect it to show. 3i Atlas demands that willingness, demands that we look harder, demands that we measure more carefully, demands that we calculate more honestly, demands that we admit when probabilities push us toward conclusions we did not anticipate. Tonight, December 19th, 2025, we get our best chance to answer questions. 3i Atlas poses, or discover that those questions only lead to deeper mysteries. Either way, the comet does not TMT care. It continues outbound, past Earth, past Jupiter, past Neptune, past Kuiper Belt, past Oort cloud, past solar gravitational boundary, back into interstellar space, back into the galaxy, back into 7 billion year journey that never ends, back into the dark where it came from, back into the void between stars, where countless other objects drift unseen, until one of them enters another solar system, until another civilization looks up and sees what we see tonight, and wonders as we wonder what it means.